Welcome to Brain Vision.
So here for part A, this would be the three free body diagrams that we need to show. For part B now, we need to apply Newton's second law for the two blocks. And we're going to say that, of course, the positive x direction is going to be to the right. So we can say that for the mass A, the top block, we're going to say that the sum of forces in the x direction would be equal to force tension sub A minus m sub A g sine of theta sub A. And this would be equal to the mass of A times the acceleration of block A. Here we're going to just say that the acceleration would be the total acceleration of the system. So therefore, force tension sub A would be equal to m sub A multiplied by g sine of theta sub A plus A. At this point, we can solve. So the force tension sub A would be equal to 8.0 kilograms multiplied by 9.80 meters per second squared times sine of 32 degrees plus 1.0 meters per second squared. And we find that the force tension sub A rather would be 49.6 newtons. Now for mass of B, we're doing the exact same analysis. Sum of forces in the x direction would be equal to mass sub B g sine of theta sub B. This would be minus force tension sub B. And this would be equal to the mass sub B times the acceleration of the system. We find that the force tension sub B would then be equal to the mass sub B times the acceleration of this, mass of B times g sine of theta sub B minus the acceleration of the system. And now we can solve. So 10 kilograms times 9.80 sine of 61 degrees minus 1.00 meters per second squared. And we find that the force tension sub B would be equal to approximately 75.7 newtons. So this would be our force tension sub A and our force tension sub B for part B. Now for part C, net torque on the pulley is caused by these two tensions. We're going to say that clockwise is positive. So when we're trying to calculate the torque, the sum of the torques would be equal to the force tension sub B minus the force tension sub A times radius r. So this would be 75.71 minus 49.55. Let's not round into the very end. Newtons times 0.15 meters. And we find that the sum of the torque is going to be equal to 3.92 Newton meters. Again, because this is positive, this would be clockwise. Now we're going to use Newton's second law to find the rotational inertia of the pulley. We know that the tangential acceleration of the pulley's rim is the same as the linear acceleration of the blocks. We're going to assume that here the string doesn't slip. So we can say that the sum of torques would be equal to I times the angular acceleration, which would be equal to I times the tangential acceleration A divided by R. And so this would be equal to the force tension sub B minus the force tension sub A multiplied by R. And we can find I. So I would then be equal to the force tension sub B minus the force tension sub A times R squared divided by A. Let's solve 75.71 minus 49.55. Units here would be newtons, multiplied by 0.15 meters, quantity squared, divided by the tangential acceleration of 1.00 meters per second squared. And we find that the moment of inertia, I, would then be equal to 0.59 kilogram meters squared. So this would be our final answer for part C. That is the end of the solution. Thank you for watching.